Hi everyone, welcome back to Tech Margadarshi. In this part, we will explore object oriented programming, OPS, concepts in Java. OOPS helps us design programs that are closer to real world scenarios. We will understand how Java uses classes, objects, and relationships to build structured applications. These concepts form the foundation of advanced Java development. So let's get started. In this slide, we are getting an overview of the core OOPS concepts in Java. First, an object is a real world entity. It has state, which is represented by variables, and behavior, which is represented by methods. In Java, objects are created from classes and are instances of those classes. Next, a class acts as a blueprint or template. It defines the common properties and methods that all objects of that type will have. Encapsulation means wrapping data and methods together into a single unit. It helps protect data using access modifiers and improves security and control. Inheritance is a mechanism where one class acquires the properties and methods of another class using the extends keyword. It promotes code reusability and reduces duplication. Polymorphism refers to the ability of a method to behave differently in different situations. In Java, this is achieved using method overloading and method overriding. Abstraction focuses on hiding internal implementation details and showing only essential features. It is implemented using abstract classes and interfaces. Association represents a relationship between two classes that use each other. It shows a has a relationship where both classes can exist independently. Aggregation is a weak form of association. One class contains another, but the child object can exist independently of the parent. Finally, composition is a strong form of association. Here, one class completely owns another, and the child object cannot exist without the parent. In this slide, we are learning about class in Java. A class is a blueprint or template used to create objects. It defines data, which are variables, and behavior, which are methods. A class itself does not occupy memory. Memory is allocated only when an object of the class is created. Now let's understand this with the example shown on the screen. Here, student is a class. The variables ID and name represent the data members of the class. They store information related to a student. The display method represents the behavior of the class. This method prints the student's ID and name. So, in simple terms, the class defines what an object will have and what it can do, but the actual data is stored only when we create an object of this class. Now, let's understand object in Java. An object is an instance of a class. It represents a real world entity and holds actual data. Memory for an object is allocated using the new keyword. Now let's understand the code example shown on the screen. Here, test is the class that contains the main method. Inside the main method, we are creating an object of the student class. Student Samban new student. This line creates an object named as and allocates memory for it. Next, we assign values to the object's variables s.id equals 1, s.name equals Alice. These values are stored in the memory allocated for this object. Then we call the method s.display. This method prints the values of ID and name for this specific object. So to summarize, class is the blueprint. Object is the real instance created from that blueprint. Objects hold actual data and perform actions defined in the class. Now let's understand encapsulation in Java. Encapsulation means binding data and methods together into a single unit. It is mainly used to protect data and allow controlled access. In Java, encapsulation is achieved by making variables private, providing public getter and setter methods. Now let's understand the code example. Here, we have a class named employee. Inside the class, the variable salary is declared as private. This means it cannot be accessed directly from outside the class. To access this variable safely, we use two public methods: setSalary int es. This method is a setter. It assigns a value to the private variable salary, getSalary. This method is a getter. It returns the value of the private variable salary. Now let's look at the test class. Inside the main method, we create an object of the employee class. We set the salary using eSetSalary 50,000. We retrieve the salary using eGetSalary and print it. This way, direct access to data is restricted. Data is modified only through methods. Security and control are maintained. So, encapsulation helps in data hiding, security, and better code maintenance. Now, let's understand inheritance in Java. Inheritance is a concept where one class acquires the properties and methods of another class. It helps in code reusability and creates a parent child relationship between classes. In Java, inheritance is achieved using the extends keyword. Now, let's understand the code example. First, we have a class called parent. This class contains a method named show, which prints a message saying parent class method. Next, we have a class called child, which extends the parent class. Because of this, the child class automatically gets access to the methods of the parent class. Inside the child class, we have another method called display, which prints child class method. Now let's look at the test class. Inside the main method, we create an object of the child class. Using this object, we call show. Even though show belongs to the parent class, the child class can access it due to inheritance. We also call display, which belongs to the child class itself. This clearly shows that a child class can reuse parent class code. Inheritance reduces code duplication. It helps build hierarchical relationships between classes. So, inheritance is an important concept for writing clean, reusable, and maintainable Java code. Now let's understand polymorphism in Java. Polymorphism means many forms. In Java, it allows the same method name to behave differently based on the situation. Polymorphism is mainly achieved in two ways: method overloading, compile time polymorphism, method overriding, runtime polymorphism. Let's understand both with examples: method overloading, compile time polymorphism. First, let's look at method overloading. In this example, we have a class called calculator. Inside this class, the first add method takes two integers and returns their sum. The second add method has the same name, but it takes three integers. Even though the method name is the same, the number of parameters is different. The Java compiler decides which method to call at compile time. So this is called compile time polymorphism. This helps us write cleaner code, avoid creating multiple method names for similar operations. Method overriding, runtime polymorphism. Now let's understand method overriding. We have a parent class with a method called show. Then we have a child class that extends parent and provides its own implementation of the same show method. Now look at the main method. Here, we create a parent reference pointing to a child object. Parent p equals a new child. When we call p.show, the child class method is executed. This decision is made at runtime, so this is called runtime polymorphism. This shows that method execution depends on the object type, not the reference type. Java supports dynamic method dispatch. Now let's understand abstraction in Java. Abstraction means hiding the internal implementation details and showing only what is necessary to the user. In simple words, we focus on what an object does, not how it does it. In Java, abstraction is mainly achieved using abstract classes, interfaces. Let's understand this using an example. Abstract class example. Here we have an abstract class called shape. Inside this class, we have an abstract method called draw. An abstract method does not have a body. It only defines what needs to be done, not how it is done. This means every child class must provide its own implementation of this method. Implementing abstract method. Now we have a class called circle that extends shape. Inside circle, we override the draw method. We provide the actual implementation by printing drawing circle. This is where the real logic is written. Using abstraction in main method. In the main method, we create a reference of the abstract class shape, but we assign it a circle object. Shape s equals new circle. When we call s.draw, Java calls the draw method of the circle class. The user only knows that a shape is being drawn. The internal details are hidden. Now let's talk about interfaces in Java. An interface is a blueprint just like a class, but it contains only abstract methods. This means it tells what to do, but not how to do it. One major advantage of interfaces is that they support multiple inheritance, which Java does not allow with classes. In Java, we use the implements keyword to implement an interface. Interface example. Here, we have an interface called animal. Inside this interface, we define a method called sound. This method has no body. Any class that implements this interface must provide its own implementation, implementing the interface. Now we have a class called dog that implements the animal interface. Inside the dog class, we override the sound method. We define the behavior by printing dog barks. This is the actual logic of how the sound works, using interface reference. In the main method, we create a reference of the interface animal, but we assign it an object of the dog class animal a equals new dog. When we call a dot sound, Java calls the sound method of the dog class. This shows runtime polymorphism. The interface hides implementation details. In this slide, we are comparing association, aggregation, and composition in Java. These concepts describe how one class is related to another class. Association represents a basic relationship between two independent classes. In this case, one class uses another class, but there is no ownership. Both objects can exist independently, and the relationship can be one to one or one to many. Aggregation is a weak has a relationship. One class contains a reference to another class, but the child object can exist even if the parent object is destroyed. The child object is usually created outside the parent class, which means there is no strong ownership. Composition is a strong has a relationship. Here, the parent class fully owns the child class. The child object is created inside the parent class, and it cannot exist without the parent. If the parent object is destroyed, the child object is also destroyed. So, in summary, association shows usage without ownership, aggregation shows weak ownership with independent objects, and composition shows strong ownership where the child depends completely on the parent. That brings us to the end of part 8. Practice the examples shown to gain confidence in OOPS concepts. These fundamentals will help you write clean, scalable, and real world Java applications. Stay connected with TECHMargadarshi for the next part of our Java learning series. Keep learning, keep coding, and grow your Java skills step by step.